Welcome back, all my aspiring mathematicians. Today I am going to show you the difference between the composition of function and multiplication of functions. First and foremost, let's define what a composition of function is. The composition of function occurs when one function is substituted into another function in place of the variable. Now, in other words, we can also go deeper and say that let f and g be two functions such that the domain of f intersect the range of g. And at times, they mostly use f and g when they're dealing with a composition of functions, or it could be g and h. It doesn't necessarily always have to be f and g. It could be g and h, or it could be f and h. Now, one thing you must know also is that there is a difference. When you are multiplying a function, you are simply multiplying the function of f with the function of g. And let's get into first defining what each of these is. Multiply a function, right? You're given a function f of x and you're given g of x, and you need to multiply the function f dot g of x, and that is saying that you're multiplying the function. Now, another way that you might see that they write this is if they write f, g, and x. So it's, once again, you're just multiplying g with x. That's what it simply means. Now, I don't want you to confuse this, right, with composition of function, where composition of function, and I'm writing f of x for function, right, and you're given f and g. Composition of function is f of g of x. That is the difference. So do not mix these up, right? Because when you mix these up, then it's going to tell you something different. F composition of g of x is not to be written as f of g, like fog of x. No, this is not the way that you write it. So do not write it this way. Please don't make that mistake. Now, f of g of x, meaning f the composition of g of x, and you can write it also simply by saying you have the f first, then the g is going to be there, right? And then you're going to have your x, and you can write it that way. So you write it this way or you write it this way, okay? Notice it's also different from this. This, you are multiplying the f with the g. This, you're taking the f and then you're substituting g of x into x wherever you have f of x. So I just want you to know the difference between multiplying function and composition of function. Without further ado, let's get into an example of me showing you the difference with dealing with math that has to do with the multiplication of functions and also the composition of function. So let's start out with our first example here. So I have f of x is given as x plus 9 and g of x is given as 2x plus 3. If you're asked first to multiply these, meaning that you're going to find fg of x, okay? And you're also going to find f of little o to show the composition, not fog, not the word fog, it's a tiny o, right? This is like a dot, which is closed. This is open, of x. So we're going to find both of these. If we are multiplying these two functions, f and g, for number one here, we are going to write what they are, x plus 9, use parentheses, and then we're going to multiply it with 2x plus 3. Now, this is pretty simple and easy with multiplying binomials. If you don't remember how to multiply binomials, you can go back and watch my video on how to multiply binomials. And in this case, it is a two sets of binomials. There also may be a situation where you might have a trinomial and a binomial that you need to multiply, or a trinomial and a monomial that you need to multiply. So let's get into this. So we're going to use a distributive property, and we're going to multiply each of these out. So x times 2x is going to be 2x to the second power. X times 3 is going to be 3x. And we're going to do 9 times 2x is going to be 18x. And we're going to multiply 9 times 3, which is going to be 27. We're going to combine all like terms here. So we have the 18 and we have the 3 to combine. So our answer is going to be 2x squared plus 21x plus 27. And that is our answer for f multiplied by g of x. So f g of x is 2x squared plus 21x plus 27. And you box your answer in this case. And you write it like this. If you don't want to write it like this, then you can write it like this, which is just f, nothing in between, with g together, and then x equal 2x squared plus 21x plus 27. And that would be your answer. Now, if we're to find the second one, all right, this is the second one. This is number 2. And we're going to do now f of g of x. So we're going to substitute what we have for the x variable in the function f with the function g of x. That is what it is simply asking you to do. So I'm going to start off first now with rewriting my function. So I'm going to have, I always like to still write my f of g here of x. I'm going to start with my first function, which is going to be, instead of using x plus 9, let's write first f of x here is x plus 9. Instead of writing x plus 9, I'm going to substitute that x with my 2x plus 3. And then I'm going to have the other part, which is the plus 9. So we have this, and I always tell my students, replace it, substitute it, and use parentheses. And you can drop the parentheses after, because now you're not multiplying. It has a plus sign there. So f of open hole g of x, f composition of g is going to be 2x, and 3 plus 9 is going to be 12. So this would be your final answer here. Okay? Substituting one into the other. As you should know by now, I always give more than one examples. But I also want to show you something else before I get into that next example. What if I say to you, find g of f of x? All right? Before we're doing f of g of x, or f composition of g, now we're doing g composition of x. All right? So what we'll do here, I always like to write my first part, which is my g of x, which is 2x plus 3. So I have that written down. But I'm not going to use this and just add the other piece to it. No. G of f of x is simply going to be, I'm starting writing this, but wherever I see the variable, I'm going to replace it with my, what I have for my f of x, which is x plus 9. I'm going to replace it. So let's get right into it. So I'm going to start with the 2. I'm going to replace my x with x plus 9. So once I replace that, then I can throw back my plus 3 here. So I'm just substituting. Notice the difference here, this versus this. So the composition of g of x with f of x is going to be, you have to use the distributive property, 2x plus 18, and then you have the plus 3. So the composition of g of f of x is going to be 2x plus 21. So this is going to be your answer. Notice the difference between this one and this one. You substituted your x plus 9 for your variable here, whereas over here you substituted 2x plus 3 for your variable in your first function. So just note that there's a difference between multiplying two functions and finding the composition of two functions. It is totally different. Do not make the mistake. Just go by the steps. One is simply that if you're multiplying, you're just going to multiply both functions together. And if you're doing the composition simply has to do with you substituting the other function for the variable in the first function. So taking the second function, substituting it into the variable that is in the first function. So that is in a nutshell what composition is all about, and don't mix the two up, please. So as you should know by now, variety is the spice of life, and I always like to give more than one example. So our next example is f of x equals x minus 7 and g of x is equal to x to the second power. And we're asked to find f of x and f of g of x, meaning the composition of it. So let's get into the multiplication first. Number one, we're going to find the multiplication here. So f of x is x minus 7, and we're going to multiply it by g of x, which is x squared. And this is easy. So fg, and we have our x is going to be, we're multiplying x to the third power using the distributive property, and minus 7x squared. So this is our answer. All right. Now, if we're doing the composition of f of g of x, then we're going to write out what f of x is first. I always tell my students to do that, because if you're not versed in math, you're going to have a little bit of difficulty to start out with. So always write the first function, and then you're going to write what you're finding. F of, do not write as big as that. You need to have a little open circle, meaning composition of. Wherever you have the x, you're going to replace it with what you have for your g of x. So in this case, I'm going to replace this with x to the second power, and I can use my parentheses minus 7. And then you just write your final answer now without you having the parentheses here as x squared minus 7. And there is the difference there. As you should know by now, variety is the spice of life. And I always like to give more than one examples. And so this example is a combination of a function that has a trinomial and another function that has a monomial. So let's get right into it. So I'm given f of x is going to be x squared plus x minus 2, and g of x is simply going to be 3x. And you're asked to find f g of x, meaning that you're going to find the multiplication, and you also going to find the composition of f of g of x. So let's get right into it. The first one, we are going to multiply. So first one, we are going to do the multiplication. Remember now, this is the difference between the multiplication of two functions and the composition of two functions. So we are going to multiply x squared plus x minus 2 with 3x. This is f, this is g, all right? This is f of x, this is g of x. We need to use our distributive property. And when we use our distributive property, we will end up with 3x to the third power, right? And we are going to also use our distributive property on this. So plus 3x to the second power, and then we're going to also use our distributive property, which is going to minus 6x. So now we're going to write it as f g of x is equals to 3x to the third power plus 3x to the second power minus 6x. And that is your final answer. For number 2, you're going to find the composition now. So I always tell my students, write your f of x first, which is x squared plus x minus 2. Now, you're going to put it together. All right? So, wherever you see x, you're going to replace it with g of x, which is 3x. So, I'm going to throw in my 3x now. So, I have 3x here, right, plus 3x here, and I always like to use my parentheses there. I'm going to put my exponent there and minus 2. So f of g, meaning f composition of g of x, is equal to, you're going to square this. So this is going to give you 9x squared. All right, because the squaring, you can square each component that makes up this monomial. So 3 times 3, which is 3 to the second power, is 9, and x to the second power is x squared, plus 3x minus 2. You can't combine any like terms here because there's no like terms to combine in this case. So you have to be very careful. And this is what your answer will be. So in conclusion, I hope that these 3 examples have helped you tremendously and that you will utilize all the steps that I did. And please note the difference between multiplying a function and doing the composition of functions. One is simply just multiplying them, and the other is taking the second function and substituting it into the first function where you see that variable. If there's no variable, obviously you can't substitute anything. All right, so be careful there. So with that being said, if you have not yet subscribed to my channel, what are you waiting for? Go ahead and hit that subscribe button. And while you're at it, share this video with others around the world so they too can be successful in math and advance to the next level. It's called level up, level up, level up, level up, level up. We all want to level up and be great at math, because guess what? Math and English goes hand in hand. You will need both of these subjects to survive in life. Trust me. If you like what you see, hit that like button and leave me a comment. And thank you again for watching, and see you soon on the next video to come. Bye now. Cheers.